about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. If you're in the Middle Tennessee area or will be traveling through here in early June, come out and meet us and Saran from the Code Newbie podcast as we launch Code Newbie Nashville, a local meetup for the most supportive community of programmers and people learning to code. Code Newbie has meetups in Atlanta, Austin, Dallas, Philadelphia, Washington, D.C., and now Nashville, Tennessee. For details about the meetup or future meetups, go to www.completedereporpodcast.com/CodeNewbieNashville or follow the link in the show notes. Welcome to another episode of Complete Developer Podcast. This week, we are continuing our series on design patterns with the structural patterns. I got a quote from sourcemaking.com. In software engineering, a design pattern is a general, repeatable solution to a commonly occurring problem in software design. And if for some reason you are listening to these back to back, you'll know that I had that quote in the very first episode. But structural design patterns are ones that work with relationships between entities and make it easier for entities to work together. And those patterns are the adapter, the bridge, the composite, the decorator, facade, the flyweight, private class data, and the proxy. But before we get started, Will, what have you been fighting this week?
I've been messing around a little bit with the early access program. ReSharper, or the company that makes ReSharper, JetBrains, has got a C# IDE that runs on Linux. And it's like the people that make ReSharper are making an IDE for my language. So I'm extremely happy about this, right? So I've pulled it down onto my Linux box, and I haven't done a ton yet. It opened, it ran, I messed around a little bit, and then I backed off. I am going to try to do some light console apps.
Was it you that sent that to me on Twitter?
Probably, yeah.
I was saying, because I knew about that from Twitter. Somebody had sent it to me, so.
Yeah, and it may have been me.
You probably buffered it.
Yeah, I totally would have buffered it. So there's that. The other thing is this weekend, I got fed up with Scrivener, which is what I use, for writing, with the book I'm working on. And I keep finding myself in a position where I get into Scrivener and the outline is screwed up and I can't, it's going to be a lot of work that doesn't really produce value to get everything clean where I can actually work. And so I finally took it and I made it dump to a tab delimited file, and I wrote a console app that streamed those pieces out into separate files, and I'm using Visual Studio Code. I was just like, here, 30 minutes, you're out of there, no more problems. And looking back at that is the most valuable skill, I think. That's like basic programming, sort of like basic plumbing.
Yeah.
It's not necessarily, hey, this is professional. It's like, I need a quick and dirty way to do this so I don't spend 6 hours on a Saturday, doing something stupid when I've got the data there and I can parse it and I can build a tree and dump out everything like I want into little markdown files and go on with my life. And, it was just quite gratifying to come up with an idea, build something, and get the results I wanted and be done with it. The more I look at console apps, the more I'm like, wow, that was a really powerful paradigm that we've just totally let fall.
Yeah, that's true.
I think that's what excites me about jumping onto Linux too. So, that's what I've been doing. How about you?
Well, I think I told you last week about getting the Mac from my sister. I have finished my Bubble Pop app for my nephew. And now I'm just working on figuring out how to get it published to the iTunes store. Just kind of working through that. I found a pretty decent tutorial that I'm probably going to work on the next week or so. It'll probably be week after next that I actually get around to it, because this week I have 5 interviews.
For development positions or for other?
Both. It's a mix. I have decided that I'm going to keep looking for a development position, but I really just need to get a job.
Yeah, a job or two where you can get a little bit of money and a little bit of stability.
Yeah, exactly. Just I need to get something where I can get a regular paycheck. I want to focus on building up my freelance business.
Yeah.
I'm going to kind of get myself a job to gain some financial stability and keep going for dev jobs, but really put my focus in building up the podcast, some of the tutorial stuff that we're working on, and my freelance business.
Yeah, that's kind of the same boat I found myself in. And, I do eventually plan to get back to it. The nice thing about the freelance business thing is that if you build something, like if you're billing based on the value you provide versus your time, if you build something that saves you time, the client still pays for it, but you just save time so you can actually get more done.
Well, I'll be honest with you. I've been listening to the Sean West podcast. Actually, I was Snapchatting with Sean McCabe, the host of that podcast, earlier today. And he's a really cool guy. I really say anybody that's especially interested in starting your own business, check out their community. They have a lot of great stuff. But he is putting together a course on value-based pricing for a business. And he's putting it together with a developer that works for the Sean West community that started off as a community member.
I wonder if I ran into either of them at MicroConf.
You very well might
the value-based billing thing, that actually came up in my mastermind group last night. I finally have gotten into a mastermind group. It's for people that are trying to build apps. It's Micropreneur Academy folks. And I've got I've got a mastermind group now, and it's really nice to be able to have people to talk to that make things happen instead of have things happen.
Yeah.
And that has come up some with one of the guys billing, because he is pushing more for that angle, because he's realized that, hey, I'm limited on my income and on my actual freedom because I'm billing based on the hours I spend, not the value I provide.
Yeah, and that's how this course came up. I'll put a link to it in the show notes.
Yeah.
It's valuebasedpricing.com, and I've just listened to the podcast episodes. They had a 3-part series on it, kind of an introduction to it, and I gained a lot just from listening to that. I'm going to take the course once I
have money to
spend. Of course, I'm also going to join their community once I have the money I can dedicate a certain amount per month to that. Also, I found the conference I want to go to out of state. And no, it's not the Sean West conference. Unfortunately, theirs happens to be around the same time as my sister's birthday, and I already have plans during that time. But it is the podcast movement. And I think I told you about this.
Yeah.
A friend of ours, Saran, over at Code Newbies,
who we're going to talk to in like 12 minutes.
Yeah, that's right. We're going to be talking to her tonight about some collaboration stuff, but she sent that to me, and it's the week after my nephew's birthday, which his birthday is on July 3rd, so it's the week of July 4th in Chicago, and I'll already be up in Cleveland for his birthday, so I'm thinking about just taking that week off. The conference is it's affordable. It's like $400 or $500.
Yeah, that's not too bad at all.
No.
Depending on what the hotel is.
Now, the hotel is the expensive part. That's around $700. And I'm hoping I might be able to talk to some other people I know that are podcasters, and maybe I can split a room with someone that I know.
Yeah.
If anyone else is going. But I just think it's awesome. One of my favorite podcasters of all time that I was listening to. It was the first podcaster I ever listened to. Kevin Smith is going to be a keynote speaker there.
Nice.
Yes. I have to go find my old VHS of Clerks and have him autograph it.
Yeah.
That's
it's. Well, you could totally go with Silent Bob anyway, right?
Oh, I'm going to dress up. But anyways, Jason, roll that funky music, white boy. This week for IoTs, I want to talk about something I mentioned last week, and that is the outdoor speaker setup for my sister's place. I told you guys last week in the intro that she was going to let me help her set up a smart home technology as they renovated the house. Well, to start off, we're going to take some pre-existing Bose speakers that the previous owner left, and I'm going to make those, I don't want to say smart speakers, but Bluetooth-enabled speakers. So what happened was, after we'd gotten everything moved in, she was setting stuff up. She brought me out to the patio area, and she's like, "Hey, do you think you can make these work?" And after looking at them, I thought, well, yeah, if the speakers work, we can wire them up. And she's like, "Well, I just really don't want wires running all over the place." She's like, "Is there anything you can do wireless?" And I said, "Yep, sure is."
What kind of range?
What do you mean?
Yeah, like how far does it have to go to be able to connect to something?
10 feet.
Okay, so 10 feet. Yeah, that's well within Bluetooth.
Yeah, I know. That's where I was like, that's 10 feet at the max. I could make it less, but that's just 10 feet to where she wants to put the receiver. And I'm like, yeah, I can totally do this. So I went online and I found a really cool little thing on Amazon that is a Bluetooth receiver and transmitter. Unfortunately, what I learned was that it's only one or the other. So you either wire in the audio and have it transmit to the speakers, or you wire in the speakers and have it receive audio from like your phone or something, or a TV. And when I looked a little further, the ones that I found that had both were
higher.
A lot higher, like 3 times the price.
Yeah, I've looked into this problem before.
And I told her about it, and she said, well, that's not out of the question. She's like, that's about how much a good sound system would cost to put it in out there. I said, yeah, but I could probably build something closer to the original price. It might be a little bit more, but closer to the one that I thought did both. And so I've been looking into it. What I'm going to do is I'm going to take a pair of Arduinos and put Bluetooth receivers on them for the speakers, and battery power those in a waterproof case.
So if it's battery powered, well, of course you'll have to make it where it's easy to change the batteries.
Yeah, I've actually already got the idea in mind. I need to kind of spec it out and everything.
What you ought to do is hook up a giant solar cell to it.
That's actually not a bad idea, considering they live in Florida.
Yeah. Of course, I mean, they get a little bit of rain, but, there's a fair bit of the time that I don't know if that'll power the speakers enough or not.
Well, given my sister and her husband, the way they are about that kind of stuff, they might be willing to pay a little extra for those solar cells.
Yeah.
Because they're paying for the project. I'm just building it for them.
It might be really interesting. I definitely would.
Yeah, I'm gonna look into that. I hadn't thought about it like that. I just thought of a couple of 12 volts.
Yeah, I saw a project that was solar related. That was something I want to build. I cannot do it in the neighborhood where I live because of the trees and because of the whole homeowners association and fire risk and all that kind of stuff. But I saw a Arduino project that had a solar array and it used that for tracking. So it was just for being able to track the sun, and I think it was also for powering a motor to turn the device. And it's not very heavy, but what it was a solar oven.
I've seen those.
So it would focus the heat in and cook something, and that looked like something that I was like, okay, I could totally do this. That's something that would actually be useful to me.
Yeah, that's really cool. I've seen those, and I've seen the solar sun tea
Yeah.
makers. Yeah, that's really awesome though. Yeah, so I'm going to take a pair of Arduinos as receivers for the Bluetooth or for the speakers to make them Bluetooth, and then build a custom receiver transceiver for with a Raspberry Pi and a couple of Bluetooth dongles for receiving from their phones, and then putting that out to the speakers. And so it's going to be a fun little project. I'm actually going to blog about it as I build it. And if you follow me on Snapchat, I will be Snapchatting about it as well throughout the process. Before we jump on into design patterns, we spoke last week about iTunes reviews, and we have one that we want to read. And this is from Lori Billington, and the title is Great Personalities. The two guys' personalities work well together to make the podcast an interesting discussion, even for non-computer geek people. Definitely a must-listen for anyone interested in programming. And so, Lori, we want to say thank you for that. And I think we're going to send her a t-shirt. Is that what we decided?
I believe that was the plan, yeah.
All right. Yeah, Lori, a t-shirt is on its way to you. Okay, so I'll bring it up for John's birthday. That's my sister that left that.
Yeah.
Hey. Will is like fighting the urge to crack up because I'm treating it like a...
Yeah, well, I mean, she actually listens and so does my wife. I mean, I think we may have a larger population of non-developers that listen than we actually know.
That's very true, because I have two or three other friends. Like, you're friends with some of them, and
yeah,
like I have a former boss that listens, and he's a minister, and we have another friend that listens that is not a developer. So we have a good mix of people that listen to the show.
Yeah.
Of course, we've known each other since college, so we've built this rapport and back and forth that.
Yeah, it comes out pretty well. So, speaking of rapport and back and forth between two different things,
yeah,
let's talk a little bit about structural design patterns.
All right, we'll start off with the adapter pattern.
Start ARF.
We will start off with the adapter pattern, and this matches interfaces of different classes. And basically, it acts as a bridge between two incompatible interfaces.
Yeah, I guess the best way to think about this, in the real world, is think about your like in a sound system. You have the stereo. You have the big plug, and then you have like the stereo mini.
Yes,
that's an adapter. In other words, I can take this plug and plug it into the big one because I have an intermediary sitting there that handles the communication between the two pieces.
No, it's a single class to join the functionality between two incompatible classes
without having to rewrite those classes.
Yeah, it kind of wraps the existing classes in a new interface.
Yeah, it's basically a way of buffering, or not really buffering messages, although you can use it for this, between two different systems. Yeah. It's a translation layer, effectively.
Yeah. The example that I found was a socket wrench.
Yeah.
You have a half-inch or a quarter-inch drive, and there's an adapter that you can put on the half-inch drive that will make the wrench work for a quarter-inch socket. Of course, I also have in here, because when I wrote these, we were still working on my parents' house, and my mom doesn't know the difference between a socket wrench and a regular wrench. So we were installing, this is funny, we were installing the toilet in the bathroom, and she had a regular wrench, and you're just going back and forth with it. And I saw her, and I was like, what are you doing? She's like, it won't tighten. I don't know. It's just not working. I'm like, because you're tightening it and then loosening it. You're not really doing anything. She's like, no. When you go back, I'm like, how does that work with that wrench? And she looked at it, and I'm like, it's a solid piece of metal, Mom.
Yeah.
She's like, I feel so stupid.
But if she'd had effectively she'd had an adapter that would allow that to go back and forth. Well, I mean, if she'd had
the right type of wrench.
Well, what is that though? Right? It's an adapter between the handle and what you're connecting to.
Well, that's true. That's very true. Good point.
It's changing the mechanical angle so that you're not untightening.
Yeah, that's true.
And causing a problem. I mean, this is effectively a real world metaphor for the same thing.
Mm-hmm. Yes, yes. So, bridging into our next design pattern.
The bridge.
Exactly.
So we're bridging into the bridge.
Yes.
And we're recursing into the recursion. Yeah. Recursively.
Well, you know, that's just how we roll.
Yeah.
So a bridge.
It's going to be that kind of party.
Oh, yeah. So a bridge separates an object's interface from its implementation. The interface acts as a bridge between concrete classes and the interface implementer classes.
Right. Now, I tend to use this like with I guess the best way to look at this is if you have a message that's coming over and you've got a bunch of different message types, but you have one place that they all go into, that thing can decide where to dispatch.
Okay, yeah.
And that tends to be, so calling
this
it
reminds me of one of the questions I was asked in an interview, which was when an HTTP request comes in to the interface, how does it decide where it goes?
Right. Well, like in C#, it's going to look at the attributes on the method and say, does this take an HTTP GET or an HTTP post? And then like put and delete end up being under the hood actually kind of posts a lot of times, depending on the web server implementation. And then they kind of broker it through and they do some hacky stuff. Like
I'll be honest, I didn't do too well on that particular question because I didn't understand it until I asked a few more questions and got him kind of to explain what he was asking. And then I was like, oh, yeah, get versus post. Yeah.
Yeah. Cause under the hood, it's a payload is hitting a server and the server goes, okay, which method am I dispatching to? The server's acting as a bridge.
Yeah.
You'll see the same thing with, message queuing, right? You know, like, especially like with Rabbit and things like that, you write a message into an exchange and then the exchange fans it out into queues that are listening. And sometimes that exchange may actually look and go, okay, if the message matches this pattern, then it goes over here. If it matches this pattern, it goes over here. And if it matches both, it goes to both.
Okay.
Because you can also have that sort of thing happening.
Yeah, that makes perfect sense.
But it's a layer of indirection so that I can say, it's like, here's the thing, deal with the thing. I don't care how you deal with it, just do it.
Yeah.
Well, it's a delegation pattern.
Yeah, it goes beyond encapsulation to insulation.
Yes.
And the example that I found, like the real world-ish example, is a KVM switch.
Yeah, I can see that because, you basically, you can send it commands that go to one machine or the other based on its internal state.
Yes.
At the time, but like your connection, like your video connection and all the other connections that are going through a KVM switch, by the way, is a key, it has a keyboard, the video and the mouse, and you can connect multiple computers.
Yes.
And depending on the state of the switch, it's which computer it's going to. Mm-hmm. And so that's a fairly good example of a bridge pattern.
Sorry, I just assumed everyone knew what a KVM switch was.
Yeah.
My bad on that one. I didn't think about that because I get a little geeky sometimes and forget.
A little. Just a little. Yeah.
Yeah. So, next we have the composite.
Right. And a composite pattern is where you're building something up by composition. A way to think about this is, well, a bill of materials type situation where it's like I'm taking the pieces that do different things and I'm going to construct something that I can talk to that talks to the individual pieces. This can be somewhat similar to the bridge pattern. A lot of these patterns have a little bit of bleed over. Yeah,
we've discussed that in previous episodes, how a lot of them kind of, they blend. The idea here with design patterns is not these are the way things are. These are patterns that came about to help us as developers understand the abstraction.
Yeah. Well, I mean, the difference between a door and a window is how big it is and how close it is to the floor.
Sometimes.
Yeah, sometimes. Right? Like they're still both holes in the wall.
Yeah.
So the idea behind this though is to be able to treat a set of objects or a group of objects or a nested hierarchy of objects as a single object. In other words, you talk to the root and the root dispatches the calls on down. A good example of this is an HTML document, right? You've got the actual HTML body, or the HTML document, and then inside that you've got a head and a title, and then the head contains the title and usually a bunch of script tags and a bunch of metadata, and then you have the body tag, and it's got the actual stuff that's the visual elements, plus some other crap if people really, or people put script tags in there, and they'll put, a lot of different things in there. But you can deal with it as a document by saying, hey, document, get me this element with this ID. Well, the document doesn't necessarily know. It dispatches the calls to its children, and those children go, okay, is this me? If it's not, they call out to theirs, and it basically does a search of the entire tree.
Okay. That
they do some optimizations realistically that make that not quite so bad, because otherwise your runtime would be really slow.
Yeah.
But effectively that's like a naive implementation.
Huh. I hadn't thought about it that way. That's interesting. I was thinking more like directories.
Yeah, directories is another good example, like a file system.
Yeah, a file system. Directories that have entries that could also be a directory.
Yeah.
And so, like, when you're talking about searching, you go into one, and then you could go deeper and deeper in.
Right. And there's multiple ways to do it too, right? Like, so when you start doing things where you're dinking around with trees or nested structures, there's a couple of different algorithms. Like, you could do breadth first, where like you go to a level and you search everything on that level and then you go down. Or you can do depth first, where you search, you go down to a node, and okay, it's not it. It immediately goes to its children and comes back up, and then goes to the next node and goes down.
Okay.
And depending on the way the way that objects tree structure is laid out, and depending on the way that you tend to query it, one of those or the other is better.
That makes sense. The example I found for kind of real world example in a way is algebraic functions.
Yeah, because you can compose functions, right?
Yeah.
If h of x equals f of g of x.
Yeah.
Right. I mean, that's the way that your mathematical functions tend to work.
Yeah. It's like you
well,
have
that
functions.
is how they work. It's not that's how they tend. That's how they work.
Yeah. It's like you have functions with variables, and the variable could be another function.
Yeah.
And that's...
Well, it is another function.
Well, yeah, that's true.
Because the function, even if it's a constant, it's a function that has that value. And this is a mathematical understanding that's, I think, kind of lost on a lot of programmers. When you start really doing a lot of things with expression trees, you start to realize the power of the simple understanding of how a mathematical function works and how those are composed. Because again, it's still a tree structure. In a lot of languages, I think you can do this in Python. I know you can do it in C# because I have to do it way more than I care to. Is actually taking an expression tree and going down and figuring out all the nodes. Because, like, for instance, I can take a chunk of C# code that's in an expression tree that some programmer built up, and I can turn that into SQL. That's how language integrated query works. Or I could take it when it's an OData object coming in, from the web, basically, and I can turn that into an expression tree that Link then parses and turns that into SQL.
Okay.
Right. So it's that whole thing of searching a tree, and I'm treating that entire expression as a set of objects that I access through the root and go down. And I probably really went off into the weeds into this.
Oh, no, you're actually being very helpful, because this is one of the ones that when I was writing the show notes or the outline for this, I had the most difficulty understanding. And I even have in here under my example, needs a better example.
Yeah. Well, the way this one and some of the others, but this one in particular, gets explained is absolutely terrible. Mm-hmm. And part of that is because there has to be some understanding of mathematics to really wrap the head around this thing. But the other problem is just because you understand math doesn't mean you have to speak the math to explain it. And
what I found was that the explanations were trying to get around speaking math. And that's why it was so difficult. And that's why I came up with the algebraic functions example kind of off the top of my head, because I'm like, well, this is what makes sense to me.
Well, and of course we do this in objects, right?
Mm-hmm.
Versus functions. But what is an object? It's the return from a constructor.
Yeah.
In a lot of senses, not quite. And I know there's some computer science guy with Coke bottle glasses that are like a 1/4 inch thick that's, screaming at his car audio. But like if you think of a object in that sense, in the way that, for instance, JavaScript objects are, this is a function. It has a scope. It has a return value. It has stuff that is being exposed out, right? Because it's basically a dictionary, a key value pair, some of which are functions.
I think I said that when you first started explaining object-oriented programming to me, over 2 years ago now.
Yeah.
And you kind of went into the details that.
Yeah. And most, that's a very strange place for most object-oriented programmers to be, because they, we all have a tendency to think of objects as static things versus, hey, this is a return from something else. Even if that thing is a constructor. Our languages get in the way.
Yeah.
But effectively, it's like, hey, this constructor, or this means of creating this object, it's not just the constructor strictly, because that's part of the whole pipeline of building that thing up. This object is a return from a function. It's a result of it. Now, there's some other problems too, because there's a whole idempotency, and there's some other things in the mix that you have to think about. So it's not strictly that, but it's useful to think of it that way until you find that it doesn't work.
That makes sense. So now that we've
gone full nerd,
we've constructed our objects. Let's add some responsibility to them dynamically with a decorator.
Yeah, and this is something you won't see as much in strongly typed languages, but let me give you an example. Let's say I have a class that. Oh, what's a good example? Let's say we have a class that we send a SQL statement to, and it returns a result.
Okay.
Just an arbitrary. It says, here's a data reader, or here's a data set. Here's a dictionary of dictionaries that has all the crap that came back from the database.
Okay.
Okay. This is cool. We use this object. We pass it around. We have good times, right? But then somebody goes, hey, the database is getting really slow, right? Well, what do we do? Well, if we have a function that creates this object for us, the object has a set of interfaces that for talking to it. Mm-hmm. What can I do? Well, I can make that function return an object that has that same interface, that when calls come in on it, it logs and then makes the call to the inner object that's inside of it that actually does the SQL and returns the results. Now I have logging.
Okay.
That's how the decorator pattern works. It's very handy for cross-cutting concerns. So, logging, security, caching, buffering things. I'm trying to think of some other examples. Partitioning load. So like you could say, okay, well, I'm going to call my database thing, but by the way, now I have 50 databases because I've sharded my clients into separate databases. That's shard.
Yeah, I know what you mean.
Shard with a D, not shart. I really wish they'd have picked a different verb for that. That's because every time I hear it, I giggle and I feel like I'm like 10. But like, let's say I'm breaking up my client databases into 50 different databases, right? I need a layer that can say who is the client based on some context and then pass it to their database. So I can put an intermediary in there.
So basically what you're doing is you're adding a layer or adding an abstraction to create new functionality without actually altering the original structure.
Right.
Okay.
It's an adapter pattern.
Yeah.
To a large extent, it's an adapter pattern for a specific purpose and without changing the interface.
Well, that's something that we had talked about in the first episode on this, the introduction to design patterns, where when we were talking about solving the wrong problem, you can get so many of these are so similar that it's almost like choose the wrong solution for the problem.
Yeah. Well,
am I on the right track here?
Yeah, kind of. I guess the thing is these are academic distinctions.
Yeah.
Not, like academics, a lot of times, especially in computer science, I've noticed there's a tendency for them to not have actually written anything in the real world. And I know that sounds incredibly blunt. But the idea here is it's a way of thinking about problems in such a way that you can break them down into manageable, maintainable chunks that talk to each other and can vary independently.
That's the whole concept of object-oriented programming.
that's a whole concept of structured programming, like going back to procedural. Like these patterns go all the way back. You won't really see it a whole lot in assembler, but then you're not looking at assembler a whole lot either. So,
yeah, well,
and even they do that, right? It's the idea of being able to maintain a piece of code and not have to deal with the entire rest of the system because the abstraction gets too big to handle.
Mm-hmm. That makes sense. The example for decorator that I'd come up with was modular additions to the modern sporting rifles. Like personally, my rifle is Magpul City.
Well, I'll give you a sample. Actually, because I wouldn't say like a scope is right, because that's composition.
Yeah,
is putting the scope on the rifle, but putting a silencer so the interface, like that, you're not necessarily adding to it. You're saying, hey, I want to change this output so it's not so bad. That might be a sample of a decorator pattern.
Or like adding a new stock or front grips.
Yeah. Or think about your, it's funny how many of these patterns actually seem like they come out in things like electrical systems. Think about your electrical plug, right? There's a whole lot of samples that fit with this. Let's say I make I've got the standard wall plug, but then I put something on there that plugs in and I can plug something into it. But the thing I plug it into can turn off wirelessly, right? Like you have the smart switches.
Yeah.
What is that? Well, that's a decorator pattern.
Okay.
For an electrical outlet, right?
Yeah, that makes sense.
Whereas if I say, hey, I need to convert, I need to plug in my cell phone. I'm converting main power into 5-volt USB.
Yeah.
That's an adapter pattern.
Okay.
I'm plugging a power strip, right?
The factory?
That would be a bridge.
A bridge. Okay.
Right. Because it's a bridge from the wall out. It's the receiving end of the bridge. I guess it's probably a better way to put it because the wall is sending power to something that splits it. A composite, that's a little trickier to come up with.
But anyways,
because a lot of these things, they kind of tie together.
That makes sense. Though I will say this, I was listening to an IoT podcast the other day, and the guy was talking about the smart stuff, the smart home technologies. And he was saying, it's like, it's all great, because it's so cool to be able to say, Alexa, turn off the lights in the house and stuff like that until your wife goes in and manually flips the switch and then none of it works.
Yeah. Well, I saw one where somebody actually on NPR was talking about some new piece of technology and some dude had NPR playing and he had the tech. And it was like flipping his lights on and off, and because it wasn't a smart house. It was more like a moron house.
Yeah.
You knew just enough. That's the decorator pattern, and it's basically an idea of wrapping and adding functionality. I typically use this for cross-cutting concerns, especially caching. The data access layer I built has got that sort of stuff under the hood, specifically for caching, brokering of calls, that kind of stuff.
Okay.
But it's not in the core objects. It's in something that wraps it, because then I can abstract the core out and just deal with that particular problem in that space.
Hey, coders. I just wanted to break in here to remind you that our friend Bethany Adams has published her first book titled Soulbound. And it is available for purchase on Amazon or through the link in the show notes. If you'd like the chance to win an autographed copy of the book, leave us a review on iTunes or go to www.completedeveloperpodcast.com/iTunes. We'll be drawing the winner the first week of July.
Now, the next one is the facade pattern. And for everybody that has problems with English, that is not facade. It is facade. Sorry.
This is a single class that represents an entire subsystem.
Yeah.
It basically hides the complexity and provides an easy client interface.
Yeah. And of course, this, I kind of think of this as sort of like a cross between the composite and the bridge, in a lot of ways, because it's more like I want to talk to a system out there and not have to think so much about how it's implemented. So it's a plug I connect to. And I'm trying to think of a really good example for a facade that will make sense because, it's a false front. It's usually a abstraction that cuts out a lot of details.
Well, the example that I found when researching this was customer service numbers.
Yeah.
Like you have one number to call for order fulfillment, billing, shipping. It's like you call this number and
then you have to interact.
Yes, it's just that's the
because the way I tend
example.
Yeah, I guess the way I tend to do the facade pattern. Okay, here's a sample. I'm sending a letter in the mail. I know nobody does this anymore. Right? So what do? I write my little letter. I put it in an envelope. I stick a stamp on it and an address. I'm done. I'll put it in the mailbox, obviously. Then I'm done. But beyond that, I don't go, okay, how do I route this? Right? How do I make sure that it's got the right postage? How do I get it to the right city, the right mail truck, the right mailbox, etc.? I don't care. I have a payload. I say, system, here's your payload. Leave me alone. That's a facade pattern.
No, it's the same thing with the calling customer service.
Yeah.
You call in and they say, what do you want? You say,
but there's a back and forth there. You see what I'm saying?
There's somewhat of a back and forth because you're still putting an input in when you put the address in on the letter.
Yeah, you're putting an input in, but it's kind of a fire and forget. Whereas like a customer service tends to be like walking down a tree and going, hey, okay, I call in and you say, okay, what do you want? Or you give me a list of menus, right?
Yeah.
So it's kind of a facade. Like this is one of those things that I guess like if you look at any design pattern in programming as kind of like a Cartesian space of ideas, your example's on the edge. And most examples are on the edge, by the way.
No, don't worry about hurting my feelings on this. This is an example I found online, so I'm not attached to it. I'm seeing this example though, even in what you're saying.
Yeah. The reason I wouldn't use that is because of the back and forth.
Okay.
Because the system's complexity comes out of that interface versus me going in the mailbox.
You see, what I found with this was it's a higher level interface to wrap a complex system with a simple interface, but there's still an interface there, which implies a back and forth.
Not necessarily, right? Because it
doesn't always have to be a back and forth, but there could be a back and forth.
Well, and you do think about like when you are putting input into that system. I mean, it still is a wrapper over the phone system that's figuring out who this goes to at this time of day at this office.
Yeah.
Right. So, I mean, I guess technically it is a facade. It's probably not the pattern. That's probably not the way I would use to explain it because it implicitly has the back and forth and that may not be strictly necessary. But I mean, yeah, it fits. Like
I said, this is, I found this.
The boundaries of all these are so fuzzy. I mean, it's like it comes up in interviews. And a lot of times you'll have somebody there that really doesn't understand design patterns because they haven't used them and they're testing you on it. And they want a definition like, they want this binary definition of, yes, this is a facade design pattern. No, this is a whatever. It's like, it's kind of between a facade and a composite. Leave me alone, you goober.
I loved it when, I guess this was probably about 2 or 3 weeks ago. I had an interview and, they had asked me about design patterns because it got brought up that we were talking about it on the podcast. And they asked me to describe the difference between 2 design patterns. And I think I impressed them when I talked about what each was. And then I talked about how the lines blurred between them.
Yeah. It's like species. It's it's a definition that is useful for classification. It's not 100% locked down as far as what actually happens in the real world. Like it's a gradient thing. Like most things are not things. They're kind of in an area of things.
Well, this was the same. Was the same interviewer that requested we do an episode on anti-patterns.
Yeah. And
we got into a discussion on design patterns after that. Because his response to that was, that's more than most senior developers I know about them. I'm like, well, I just wrote this very, very detailed show notes for it. So
Yeah.
It's not like I'm just like super genius. I'm like, I literally just wrote this an hour before this phone call.
Yeah. Yeah.
Like, it's like right on my mind. And so you asking me that question, and he told me, he's like, it wasn't even one of the interview questions. He's like, I just saw where you had the podcast, and you'd apparently I told the first interviewer that we were talking about these on the podcast, or it might have been right after the first one came out. And it was kind of funny because we got into this conversation, and that he was like, you guys should do an episode on anti-patterns.
Yeah.
It's like, if you're doing them on, and so I told you, and now it's on our list.
Yeah, it's in the queue along with 47 other things.
Well,
Yeah, at least it's not empty.
Yeah, that's true. That's true. So let's move on. The next pattern is the flyweight pattern, and I've heard you talk about this one quite a bit. So
yeah, and I'm trying to think of a good way to put this. Like, let's say that you have an object definition in, I don't know, let's say JavaScript, right? You're running in a limited memory environment, and those objects are large. Like, let's say they're several kilobytes in size a piece. You don't want to create 1,000 of those, or 10,000, or however many. If they have a set of data though that can be used to construct one on the fly, what you can do is you can keep just that set of data, and you can keep an array of it basically, and then look those up and create them, or put them into one that is built in a way that it still exposes that. And I'm not really explaining this very well because it's one of those things to use when you see it.
Yeah.
It's very...
So the stuff that I found on the flyweight pattern, and the reason I kind of threw you out there on this one was because you've mentioned flyweights.
Yeah, and I've used them in JavaScript.
But it's a fine-grained interface for efficient sharing. And like you said, it reduces the number of objects created and decreases the memory footprint.
Yeah. Because let's say you don't need most of the properties on something to always be resonant in memory. Like, there's just a few things that you need that's just enough to, roll one up basically when as needed, or to, put into an object and that object can interact, versus keeping multiple copies around. This gets important in a lot of languages where your functions are part of the object. I've found, like in JavaScript, because, each object is going to have a copy of the function, or could potentially have a copy of the function that could be different.
Yeah. So it from what I gathered, a flyweight replaces a heavyweight widgets with lightweight gadgets.
Yeah, I guess that's a good way to explain it. And this is a really hard pattern to explain, because it's something you don't run into a ton.
So here's my question: how does it relate to an object pool? How does it compare with it?
It's kind of like that. I guess it's one of those strategies that keeps you from creating too many heavyweight things. Like, for instance, like if you had, let's say you've got 10 connections to the database server, right? You would pool those to say, okay, well, when somebody requests a connection, give them one of these. But, if you're doing the flyweight pattern, you would have something like, okay, here's my open socket connections in this table. And there's like a flag there that says, hey, this is allocated or it's not, and who it's allocated to. And then I roll out a SQL object when I need one from that pool. So it can kind of be in that mix. It's right in there. Again, I haven't had to use this very often. I did something with it in JavaScript, and I'm trying to remember what in the world it was.
I think the reason it stuck out with me is because when you did that, you mentioned flyweights, and it stuck in my head because the term is not something you hear a lot.
Yeah. Well, you don't use it as much now as you would have 10 years ago or 20 years ago.
Yeah. Well, the example I found was images in modern browsers.
Okay.
Because the images these days can get huge.
Yeah. And so you might have a kind of like a pool of references, like where you've got that one bitmap that's used in 10 different places.
Yes. And
okay, you're drawing it in 10 different places, but you're really only creating one instance. Mm-hmm. So it is kind of a pooling thing. Again, this one's hard to come up with an example. If you get this in an interview, I would almost, unless they're in a environment that tends to be very intensive as far as memory pressure and those kind of things. Like they're doing printing and stuff like we deal with some at work. They're probably asking this question for the wrong reasons.
Yeah.
That's more of a gotcha, but yeah, I don't know of a good way to put this. Otherwise, I don't use this one a ton.
All right. So next is private class data.
Right. And that's basically, that's the core of object oriented, right? Is the idea that my class, my function, whatever my construct happens to be, has a set of data that cannot be accessed from outside. So I have a limited visibility, of that data. And depending on the language, some of them are not as strong as others at protecting it. Like some languages will go, okay, well, if I start it with an underscore, that means it's private. Now that variable's still going to be there. If you want to do something to it, you can, but it's not recommended because, bad things, TM, might happen. Other languages will hide it. C++ does this, but of course the thing about that is if you have a pointer, you can go where you need to go in your process with a pointer, including like overriding stack frames and doing all kinds of very bad things. So nothing's ever really private. It's just a way of saying, if you go to the effort to jump in here and screw around, you may have problems. And it's to keep a scope of access.
Yeah, I actually don't have an example for this one.
Well, I mean, this is OO.
Yeah.
Straight up. And functional programming too, a lot of times.
Some languages have read only.
Yeah, that's a little bit different. That's where like the private class data tends to be, okay, let's say I have an encryption class, right? And let's say we're using AES or something. And I've got the key for encrypting. Mm-hmm. Well, I don't want that hanging out on the class, just available where we're halfway through an operation, somebody can write to it and make weird things happen. So I want to put that inside the class and say, look, you can't access this. Now, most languages, that barrier can be penetrated. C#, a private member variable, for instance, you can get to it with reflection. You got to know its name, or, you can kind of iterate and you can find it. But, if you do that, you're going to have problems. You're going to have a bad time. But it's basically the idea of having a scope through which things can be accessed, or, basically a way of hiding implementation details and data so that they don't get touched. So this isn't so much a design pattern as a thing that underlies all other design patterns.
Okay. Actually, I feel like I have a better understanding of it now that you've said that than when I did the research on it.
Yeah.
So, and finally, we have the proxy. This is an object presenting another object.
It tends to be an adapter. You tend to, I see this a lot when you're trying to wrap lower level calls, or you're trying to wrap something that's a bit of a pain to deal with. You'll see this with graphics subsystems a lot, where they'll go, okay, I have an object that represents a window, right? Mm-hmm. And I'm going to draw to it. Well, what's really happening there? There's an API that was written in C that's sitting under this thing, and I'm brokering calls to it through this proxy.
Okay, yeah.
Of course, then you get to that function, and usually it's wrapping something that says, hey, I'm going to write to the video card's memory and then flip the memory to actually draw what has to be on the screen.
Let's see, what I have is that it provides a surrogate or placeholder for another object.
Yeah.
It basically adds an extra level of indirection.
Yeah, and that way you can switch out what you're calling.
Okay, yeah. The example that I found was checks are used as a proxy for cash, like bank checks.
Yeah. I'll give you a programming example, right? Every program should log, right? When something happens, like you write that out somewhere. Okay.
Okay.
Every programmer has a logging framework that they prefer. Well, how do you keep these programmers from fighting with each other? Or how do you set up the system where you can switch those out if you find one works better than another? You make a proxy. It's like, okay, we're going to call this logger, and it is going to know how to actually write to the real log instead of writing directly, because then you have to change code in like 5,000 places when something goes wrong, or you go, this logging framework doesn't work, or I can't write to the file system in this case, so I need to write to the event log, or I need to send an email. And so it just basically sits between. And it's very similar to an adapter pattern. Like those are kind of in the same semantic space, is the best way to think about it. Like they're right on the border with each other.
Okay. I follow you there. That actually makes more sense to me than the example I found. So that kind of wraps us up. But before we close everything out, Will, what do you have for us this week for tricks of the trade?
So this came up during the discussion, right? Is the whole private class data thing. And I think this is something to always bear in mind when we start talking about security concerns is what I mentioned there is the fact that no data is really private. If something is in your process and it's running on your box and it has access to things, it can get them. And this goes for, data that's inside objects. Like if it's loaded into, if it's available, you can get to it with a pointer. Now, it may be trickier to do, right? Like you may have to get the pointer for the object and then go, okay, well, I know that the data structure here is this size. And so I can jump this many bytes and then take this many bytes after that. And I have whatever that thing is. This can be very dangerous. Let's say that you are storing a password in an object, right? A user entered something and a password comes in and you're manipulating it and you go, okay, yeah, I'm encrypting when I go to the database, right? So we're good, right? But we're loading plugins. We've got NuGet packages running. We've got stuff that can do reflection, right? That's got the appropriate permissions to do that. Guess what those things can do? If somebody has something malicious in there, they can read that string. Now, they would have to specifically know where it is or they're going to be finding a needle in a haystack, but it is readable. So you actually want to be able to encrypt sensitive data at rest while it's running and store it in a structure that makes it where other things can't get to it, without the appropriate stuff. But then what happens if, let's say I'm encrypting a string in memory? Well, what do I do then? Well, what about that? The class that I'm using to encrypt, right? It's got an encryption key. It's got an initialization vector for encryption. And it's if it's a symmetric encryption algorithm, they're the same. If it's asymmetric, it's different, but it still has to have some way of actually reading that data, right? So now I have to secure those things. You follow me? So be thinking about the visibility of the private data in your objects as being, this is a construct that keeps other honest programmers from screwing up, not a construct that keeps nefarious programmers from screwing up. So that's what I got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.